Should I start?
Yeah, I'm going.
So we have set up this centripetal force apparatus, and what this is, it consists of a vertical shaft right here, and then a cross beam right up here. And from the cross beam, we've suspended this mass right here, and there's a spring connecting the vertical shaft to this hanging mass. And now what we're going to do is we're going to try to measure the spring constant of that spring. And how we're going to do that is we are going to use this string right here to stretch the spring to different distances and to see how much force it takes to stretch it. So for example, let me start here with the first one. I'm going to stretch it until that is vertical. Let me see if this looks vertical right there. Okay, and record how much force it takes to stretch it by that much. And it looks like it takes a force of, tell me when it's, does it look about vertical? I don't know.
I tried doing it, and if you look at the mass to make sure when it's vertical and then use your finger to stop where the spring scale is, then you can read it.
Right there. Okay, that was a force of 725 grams, or about 7 newtons. Okay, so that was our first data point. Let's see, should we do another one? Let's move it out a little bit. Should we keep filming, or should we just take a break?
Now, do they need to know? They need to know the distance. This distance.
I guess they do.
We should measure that before moving on to another distance, because they're going to be plotting this distance versus force.
Yeah, let's get a ruler. All right. So maybe I can put this back to where it was. Here, and stretch it so it's vertical. It's right over there. Okay, and so now what I'm going to do is I'm going to measure the distance from here to the middle of that. So that is 13.5 centimeters. And we'll have to measure the diameter of this shaft to add that on. So that's 13.5 centimeters. Okay. Now let's do another distance. Let's go out to here, let's say. And to do that, we're going to need to move this out a little bit. And now I'll stretch it again so that it's vertical. And that looks like it's about right. And that was 910 grams, or about 8.8 newtons. Okay, and the distance there was 15.3 centimeters. Okay, and now let's do another one, maybe a little bit farther out. Let's say to here. I'll slide this out a little bit more. And now I'll stretch it again, see if that looks about right. Okay, that's vertical. And that was a force of 1,045 grams, or 10.25 newtons, let's say. And the distance there was 17.5 centimeters. And let's do one more so we have more than 3 data points. Let's go way out. Push our luck. Move this back a little bit. Okay, and stretch it like that, let's say. So it's right above there. And then that was 1,720 grams, or about 16.9 newtons. Okay, good enough for now?
Good.
Should we pause?
Okay.